Hey everyone, and welcome. So, have you ever really thought about the ground under your feet? We count on it to be solid, to be still, but what if it isn't? Today, we're diving into the incredible forces that can literally move the world. Let's figure out what causes earthquakes. Okay, let's start with this big idea. We just take it for granted, don't we? That feeling of solid ground. But what if that's all just a temporary illusion? What if the entire surface of our planet is actually in the middle of a super slow motion car crash? That's really the question at the heart of all this. You see, to get a handle on earthquakes, we've got to zoom way, way out and look at the big picture. We live on a planet that is constantly, relentlessly moving. And I'm not just talking about spinning around the sun. Nope, I'm talking about the very ground we're all standing on. So what's the core idea? Well, it's actually pretty simple. Think of the Earth's crust like a giant, cracked eggshell. An earthquake is what happens when those massive, continent-sized pieces grind against each other and then suddenly, violently, slip. And these giant pieces of the eggshell, they have a name: tectonic plates. The Earth's surface isn't one solid piece at all. It's broken up into these massive slabs that are floating on a layer of hotter, kind of gooey, molten rock. And here's the kicker: they are always on the move. Now, when I say on the move, don't picture anything fast. We're talking incredibly slow. These colossal plates creep along at just a few centimeters per year. To give you some perspective, that's about the same speed your fingernails grow. It's a crawl so slow you'd never ever feel it. Until, of course, you do. Okay, so if the plates are always moving, why isn't the ground constantly shaking just a little bit? That brings us to the real heart of the problem, what I like to call the great sticking point. You know, the issue is, these plates don't have smooth edges. They're not just gliding past each other. They are rough, jagged, and massive. It's like trying to slide two gigantic pieces of sandpaper against each other. They get caught, they snag, they get stuck. And that right there is where all the trouble begins. This is such a great way to picture what's happening. Imagine you grab a stick and you start to bend it. What happens? First, it resists, right? It flexes and you can feel all that tension building up in your hands. You keep pushing, you keep adding pressure, and then snap. That sudden, violent release of energy, that is exactly what's happening miles underground. The plates resist movement, the stress builds, and then they suddenly. So let's just break that down one more time. Step one, the plates are always trying to move, pushed and pulled by forces from deep within the Earth. Step two, their jagged edges get snagged on each other. And step three, over years, decades, sometimes even centuries, that pressure just builds and builds and builds. But all that energy has to go somewhere, right? It can't be stored forever. And that brings us to the climax of our story, the sudden snap. Just picture it. Deep down in the Earth's crust, for all that time, that incredible pressure is silently building up. And it keeps on building, straining the rock itself to its absolute limit. Until it can't hold on another second. That friction gives way and you get that sudden, massive slip. So what just happened mechanically? The plates tried to move, but they got stuck. All that stress built up until the rock couldn't take any more and it finally broke. In that instant, the plates lurch forward and all that pent-up energy gets released as powerful waves of vibration. That is what we feel as an earthquake. So where do these huge, dramatic events actually happen? And is anywhere on Earth really safe? Let's take a look at where all the action is. It turns out the vast majority of earthquakes happen right along the edges of these tectonic plates. And that makes total sense, right? This is the front line. It's the geological battleground where these huge forces are constantly grinding away at each other. And get this, how the plates are moving makes a huge difference. When they're pulling apart from each other, you tend to get smaller quakes. But when they collide head-on, bam! That's where you get the pressure for the really huge mountain-building earthquakes. And then when they just slide past each other, that causes the frequent, jarring kind of shaking you see in places like California. So, after all that, what's the one thing you should absolutely remember? It's right here. If you take away just one sentence, make it this one. Earthquakes happen when tectonic plates suddenly slip after building up pressure underground. That's the whole story, right there in a nutshell. And that really brings us to the biggest idea of all. This whole process, it never stops. It's happening right now as you're listening to this. The plates are moving, which leaves us with a final, kind of mind-bending question for you. If this slow, powerful dance never ends, what's our planet going to look like in, say, 10 million years? Now, that is something to think about.